Hi friends, thank you for tuning in. Welcome to our Let's Talk Innovative Developments Facebook Live session. Today I will be talking about 3 research stories that you can find on the ffb.ca website, and I will be answering the questions that you have been sending in to us all week, so thank you for that. My name is Dr. Mary Sunderland, and I am the Director of Research and Education here at the Foundation Fighting Blindness in Canada. If this is your first time joining us, welcome. I hope you have a good time this afternoon. And if you joined our January Facebook Live session, thanks for tuning in again. The plan for today is to talk about the 3 stories that were featured in our e-news and that we've been promoting and sharing on our Facebook page, and to answer the questions that you've been sending in. And I'm going to do it in this order. So I'm going to start with talking about START therapy, which seems like a good place. Now this is the plan to treat inherited blinding eye diseases with an eye drop. And if you want to go check out the full story, you can find it on our website. It's called Scientists Are Developing an Eye Drop to Treat Inherited Blinding Eye Diseases. So after that, I'm going to talk about a new study that really highlights the importance of genetic testing when you're thinking about developing new treatments. And the full title for that story on our website is On the Road to Personalized Therapies for Blindness. New study reveals why genetic testing is vital. And then third, I'm going to shift gears to talk about a really cool study into the eye disease that's called age-related macular degeneration, or AMD. You can find that full story on our website with the title, Your Gut Influences the Development of Blinding Eye Diseases. So lots of people sent in questions about how these studies apply to them. Excellent general question. So I'm going to answer your questions, but throughout this session, really do my best to describe how these research findings apply to a variety of different eye diseases. So I have plans to answer some specific questions, but if live questions keep coming in, I will certainly protect time at the end to return to those questions and talk about things in more depth that might have you interested. Okay. Let's dive into START therapy. Now, before I get into the questions that you've sent in about START therapy, I'd like to start by just giving you just a general overview of the full story that you can find on our website. So START therapy is a really bold and exciting plan to treat a variety of different blinding eye diseases with a simple eye drop. So I saw some funny comments on Facebook that, you know, it would be even better if this was like a nice candy. And so we'll get the researchers working on that too. So the idea is that if successful, START therapy would work not just for one blinding eye disease, but hopefully for a variety of different eye diseases. And we are really proud to be funding this research thanks to donors like you who make the research possible. And this research project is being led by Dr. Cheryl Gregory Evans at the University of British Columbia. And Dr. Gregory Evans was actually going to try to tune in today. And so if she could sneak away from the lab, she might just be online. So we'll hope she's there in case you have even more specific questions for her. So what you really need to know is that genetic eye diseases are called genetic eye diseases because they're caused by gene mutations. And we don't need to go deep into the science of gene mutations, but you should know that mutations are changes to the genetic sequence, and these changes impact your DNA's ability to make proteins. And in the case of blinding eye diseases, it's proteins that are, important for vision to work. And Dr. Gregory Evans' research is focused, Cheryl's online. Hi, Cheryl. We're so glad you could join us, Dr. Gregory Evans. Excellent. So now I really have to get this right. So Dr. Gregory Evans' research is focused on a specific kind of mutation, and it's called a nonsense mutation. So a nonsense mutation sort of functions like a biological stop sign. You can imagine inside your cells, DNA's there, things are kind of working along, getting ready to make the protein, and then the machinery that's required to make the protein hits this stop sign. And so it stops making the protein. And what happens is you end up with these kind of half-made proteins that can't really do their job, they don't function, and then vision doesn't work as a result. So what Dr. Gregory Evans and her team have discovered is a way to kind of keep, they call it start therapy, because they find a way to get that machinery to go through the stop sign, go past the stop sign, and keep going until the very end when that protein is fully functional and ready to work in the cell as it should. So with that in the background, it makes a lot more sense for me to then go to some of the more specific questions. So I have kept a list of them here, and of course what many of you are really interested in is which diseases is this going to work for, which genes is this going to work for. So this is a question that was asked by Sharon, by Aways, by Emma, and also a lot of questions about, will this work for retinitis pigmentosa? I see that some of you are just joining us. For those of you who are just new online, we're talking about Dr. Cheryl Gregory Evans' research at the University of British Columbia to develop an eye drop to treat inherited blinding eye diseases. And so something else that you should know is that the disease retinitis pigmentosa, or RP, is really an umbrella diagnosis. And it catches all kinds of different rare diseases that share a few things in common. They're caused by a genetic mutation that results in this slow degeneration, sometimes a bit faster, degenerative loss of the photoreceptors. These are the cells that are required for vision to work. Now, there are many different kinds of retinitis pigmentosa, and Dr. Gregory Evans has started focusing in on 3 different kind of subtypes. So the first type that she's really focused on is a rare form called Leber's congenital amaurosis, or LCA for short. And specifically, she's looking at 2 different gene mutations that lead to, or mutations in 2 different genes that lead to LCA. So the first gene she's looking at is one called RPE65. This is a great gene to start with because there are so many different and excellent ways to study RPE65 in the lab. The next gene that she's looking at is one called RD3, which is also involved in LCA. She's also begun work on another form of retinitis pigmentosa called choroideremia, and her work in choroideremia is focused on the gene REP1. And what's really interesting about that is that if you have choroideremia, the chances are about 70% of the people that have choroideremia have one of these stop mutations in this REP1 gene. So that's a really appealing disease to take a look at as well. And the final, I shouldn't say the final, I should say the next disease that she's looking at is another form of RP called Usher's syndrome. So those are the 3 that she's really started with. Will it work for other kinds of RP? Certainly that's the hope. And the way that you can tell if the kind of RP that you have is the kind that could really stand to benefit from the work that Dr. Gregory Evans is doing is you'd really need to get a very specific genetic diagnosis. Sometimes it's called a molecular diagnosis. So you can learn more about exactly what genes you have that are involved in your RP, and even more specifically, what kind of mutation in the gene. Now, this kind of information is something that you can get by working with an ocular, a genetic counselor who specializes in ocular genetic testing and genetic counseling. And I know that is easier and more challenging depending on where you live in Canada and where you live in the world. So perhaps we can return to that question and discuss it in a little bit more depth later. Now, I see some other comments coming in here. I see a question from Yassine. Will there be a genetic treatment for each gene? So this is another good question. I'm going to do my best to answer it, but Dr. Gregory Evans, if I get this wrong, please feel free to elaborate. So the way that we describe it in our story, and my understanding of the work that they're doing, is there are kind of two different drugs that they are working with to get this kind of start therapy working. So it's really like what's in the eye drop. So the eye drop contains two different drugs. The first one is called Agerelated, and the second one I have a little bit more trouble pronouncing. I think it's, let's see if I can do it, Amlexanox. So we can write those words in the comments so you can learn a little bit more about those drugs. What's appealing about them is that they have been approved to use for other indications, meaning these are drugs that were developed to treat other kinds of diseases. And it was really cool that Dr. Gregory Evans and her team realized, oh, hey, this drug combination that can work in other diseases might also work for inherited blinding eye diseases. So she's working with her team, including Dr. Kevin Gregory Evans, who's also at the University of British Columbia, to test if this drug combination of Agerelated, Amlexanox, if this can work for a variety of different genetic mutations. And they actually first got started with a different eye disease called aniridia. And that was another question that came in through our Facebook page, a question from, I think it was Tim. Yeah, so Tim was wondering, oh, is this, your son was born with aniridia, would this work for him? So, we really hope so, Tim. And actually, Drs. Kevin and Cheryl Gregory Evans are currently doing a clinical trial in people to test if this start therapy can work in people who are living with aniridia. So you should know that we can't say, yes, this start therapy works and go to your drugstore and buy it. That was another question that came in. That was a question from Yassine. Actually, Yassine said, where can I get these drops? Are they available? So no, they're not available, but a clinical trial with people is a way that scientists can learn and really determine if this works as a treatment. And the Gregory Evans started this trial. There are many different arms of the trial. That sort of means there's different sites where this is happening in Canada, also in the United States. So in Vancouver, where Dr. Cheryl and Kevin Gregory Evans are doing sort of one of the Canadian sites of this trial, they are still enrolling new trial participants, people who might be interested to test if this potential treatment would work for them. I'm always hesitant to say like treatment and clinical trial in the same sentence, because I think it's really important to remember that if something's being tested in the clinical trial, it's not a treatment yet. That's the whole point of a clinical trial, to figure out if it works as a treatment. So Dr. Gregory Evans actually encouraged Tim and anyone else with aniridia who might be interested in participating in this trial to contact her team to learn more. So we can share the link to that aniridia trial on the Facebook page. So it's really exciting to see that this kind of approach is so promising. They're already testing it in people, and I think that makes us excited here at the Foundation Fighting Blindness. Other questions that we wanted to talk about with START therapy, especially since Dr. Gregory Evans is online. I have another really good one about specifically the kinds of mutations that this would work for. So we talked about the kinds of genes, but there was quite a sophisticated question that came in from Dominique. And the question is, would this START therapy also work for compound mutations, meaning there's a missense and a nonsense mutation? So that this question makes a little more sense to everybody else out there, you have to remember that there are many different ways that people can have an inherited retinal eye disease. So you can have a dominant form, meaning that just one gene is mutated, or you can have a recessive form where you have two genetic mutations. So that sort of gets to Dominique's question about a compound mutation, if there's a missense mutation and a nonsense mutation. So I'm really grateful that Dr. Gregory Evans chimed in beforehand to make sure that I got the right answer to this question. And the idea is that yes, hopefully START therapy would work for this compound mutation, this combination. The idea is that the drug, the START therapy, would target that nonsense mutation. So that's the stop sign. And if it could work for that nonsense mutation and get a functional protein, just one functional protein working, hopefully that would be enough. So it wouldn't fix the missense mutation, but by fixing that nonsense mutation, by going through the stop sign, you'd have enough protein to get some function. Other questions. There was also a question about whether this START therapy would work for juvenile retinoschisis, I think was the question. X-linked juvenile retinoschisis. And so that's also a great question. And I don't believe that Dr. Greg Evans and her team are focused on retinoschisis right now, but there is actually some really exciting work in gene therapy happening right now for this disease. There isn't currently a Canadian site for the trial, but we will share a link to more information about the clinical trial that's testing if a gene therapy could be used to fix the RS1 gene that's involved in juvenile retinoschisis. So the RS1 gene is involved in about 95% of the cases of people who have this disease. And the trial is looking to see if by sort of replacing the gene with a functioning gene, you could restore function. So this is something quite separate from START therapy, but hopefully something hopeful for you to look into in a little bit more detail. Now with that, I'm going to move on to our next story. So thanks again, Dr. Gregory Evans, for listening in. And if I made any mistakes or we want to add some more details, I'll be working with her to do that. So the next story that I wanted to move to is one that was contributed by Ruan Lai, who's also at the University of British Columbia. I bet she bumps into Dr. Gregory Evans in the hall sometimes. So I've had the pleasure of meeting Ruan a few times, and there's something that's really special about the work that she's doing. It sort of touches me because Ruan actually also lives with RP. She's researching RP. She's doing incredible work, winning awards. This study that she's just published is getting all kinds of attention. And at the same time, she's living with RP. So she's really motivated and really gets it. Before Cheryl goes, I should just actually give a little plug that both Dr. Cheryl Gregory Evans, Dr. Kevin Gregory Evans, and Ruan Lai will all be joining us in Vancouver for a speaker series that we're organizing the evening of March 1st. So I didn't want to forget to mention that. We can share some more details about that event in the comment section. So back to Ruan's story. So this is the second story, which has kind of a lengthy title, but I'll say it again so you can follow along. The full title of the story is On the Road to Personalized Therapies for Blindness. New study reveals why genetic testing is vital. So what do you need to know about this story? Well, let's go back a little bit and think about how I was talking about RP, retinitis pigmentosa, as like this umbrella term. And over the years, we've been learning more and more about how to give like a finer, more specific diagnosis to people by giving a molecular diagnosis, sometimes called a genetic diagnosis, where people understand not just what gene is involved with their disease, but what kind of mutation is involved in that gene. So before we knew a lot of those details, people have been trying to develop treatments for this disease. And people realized, I don't know, maybe like almost a decade ago, that a drug called valproic acid, sometimes it gets called VPA for short, seemed to have like a beneficial effect on people, on animal models of retinitis pigmentosa. And these results were so promising that that there was enough evidence to do a clinical trial to test if VPA, if valproic acid, could work as an effective treatment for RP, and specifically for autosomal dominant RP. And what's happened is this trial's been ongoing. They've enrolled, I think, more than 200 people. They've stopped enrolling. They've completed this study, and I would suspect that now they're just kind of gathering their data. So we don't know what the outcome of that study is. I suspect that they will probably, the scientists who led that study and led the clinical trial, will probably be talking about it soon. So kind of keep that in the background. And that made Ruan and her supervisor at the University of British Columbia, Dr. Orson Moritz, it made them really interested in, well, you know, what is it that valproic acid does? Like, how is VPA functioning in RP? And because there's so many different questions, like, do you think it does the same thing depending on which gene is mutated? Because we know that, you know, there's more than 60 different genes that get mutated in RP, and we learn more and more details about, you know, different kinds of mutations as time goes on. And they have been working in frog models. You can do really interesting and intricate genetic studies in frog models, and it allowed them to have very surprising results, where they learned that if you take valproic acid and you add it to frog models with a certain genetic mutation, it makes their retinitis pigmentosa a lot better. So it seems to work with some genetic mutations. But if you put it in other models where a different gene is mutated, it actually makes the disease progress faster. So it makes the disease worse. And this is kind of alarming, but also really highlights the importance of trying to understand a full diagnosis before you move forward with, you know, engaging in an experimental therapy. So I'm going to, you know, we had some questions about specifically what genes, and you know, I'm going to be sharing some of those more details in the comments in a follow-up, because I'm just currently back and forth with Ruan about that. And I think the real take-home message is that you really need to understand what's happening with each specific disease, because this umbrella term is so big and there's so many different things happening depending on exactly what kind of genetic mutation you have. And that's like a big take-home message from this study. Now, I should also highlight another question that came in about Ruan's study is, This is a question from Linda, and it's about genetic testing. Is there a way for Canadians to be tested for free? She just really emphasized that the cost is a hindrance. She says this is a hindrance to identifying genetic mutations. We couldn't agree more with you, Linda. And so I think we've mentioned this before. We really want to raise awareness about the importance of genetic testing, of getting access to genetic testing. And there are certainly some centers of excellence where they've figured out how to get your test reimbursed through the Canadian government. But it's certainly not easy to get it done, and not as easy as it should be. So that's on our agenda of things that we want to make sure change in Canada. And I know that there are many different initiatives happening around the world to make sure that genetic testing is more accessible. Oh, amazing. There's a question coming in from Maria in Italy. Do you have any study about Alström syndrome? Now, Maria, that's a question I can't answer off the top of my head because it doesn't sort of directly relate to the stories that we're talking about now, but I'll do some more research into this syndrome that you're mentioning, and hopefully we can get to your question later. So that's really what I'd prepared to speak about with Ruan, and I want to make sure, we're waiting to hear the stories from that BPA clinical trial. We hope that they're good news, but again, it sort of gets to my message about clinical trials are a really important step on the road to treatments. So that's the stage where you figure out if something's going to work in people, and after it works in a clinical trial, that's when it becomes a treatment. So we'll keep you posted about any developments with valproic acid in the months ahead. So now I'd like to move forward. Oh, I see another question coming in. A question from Nazira, who does genetic testing in Toronto? That's a great question. It's a local question for us. It does depend on your age group. So we work really closely with the Hospital for Sick Children, Sick Kids, where we have the Foundation Fighting Blindness Patient Registry, and that's led by Dr. Elise Ayon, and she's incredible at making sure that you can get your genetic testing done and get it reimbursed, so get it paid for. But I have to say that, Sick Kids is the hospital for children. So that is where our registry is housed, and I can say a little bit more about the registry. Perhaps towards the end we can share some more details in the comment section. But there are some different places where if you're an adult, you can get your genetic testing done. Mount Sinai Hospital is a great place. So we can have more specific contact information in the contact section. Contacts. We can have the contacts in the comment section. Okay. Moving right along to our third story. So we've been talking a lot about inherited genetic blinding eye diseases, and now I'm going to shift gears to talk about age-related macular degeneration. Now, even if you are here because you have an inherited retinal eye disease, you might want to stick around because age-related macular degeneration, or AMD, is one of the leading causes of blindness around the world. It's the leading cause of vision loss in people over the age of 55 around the world. It's so widespread. In fact, I would say that AMD is so prevalent, it's sort of the reason why we all just accept that, aging is just aging and vision loss just kind of go hand in hand. It's so prevalent, you just kind of expect to lose your vision as you get older. But we at the Foundation Fighting Blindness, we don't think that you should just accept that you're going to lose your vision when you get older. I mean, I think I love to read. I think about how incredibly valuable it is to have vision at every stage of life. So AMD is incredibly important, and that's why we're going to spend some time talking about it as our final story. And there's been some really exciting work. This is actually hot off the press. We published a story by Dr. Mike Sapia in December. Now, he's an incredible researcher based in Montreal. He's a Canada Research Chair in retinal biology, so he's a real retinal specialist. And he's been working to try and understand why is it that the dry form of age-related macular degeneration, this is the most common form that affects sort of 90% of the people who have AMD. Why does this dry form progress into what is called the wet form of AMD? And this progression only happens in about 10% of the cases, but the vast majority of vision loss and blindness happen in this wet form. So basically, if you have dry AMD, you don't want it to become wet AMD, and we don't really know why the dry form becomes the wet form. So that's like a big open research question that we're trying to get a better handle on, because we give some pretty general information, like if you have dry AMD, we know you shouldn't smoke, you should eat healthy, you should wear sunglasses, just like general health tips that seem to apply to anyone, whether you have AMD or not, really. And we also recommend that you check your eyes very regularly with an Amsler grid. This is just, it looks like a piece of graph paper, really. And if you have dry AMD, you should look at this graph paper, pretty frequently, once a week, once a month, and just cover one eye at a time and see if those straight lines have become wavy in any way. And that's one of the early telltale signs that you might have, be developing wet AMD. And once you have wet AMD, there's lots that you can do. There's, injections that you can take. There's a lot that you can do to manage the disease. But a big research question that we're trying to understand is, why does the dry form become the wet form? And this is what Dr. Mike Sapaya's research really shed some interesting light on in December. So he's been working with animal models, and what on a kind of a hot topic, which is called the microbiome. So I don't know if you've heard much about the microbiome. If you haven't, if you look around for it, I bet you'll see it in news titles and science stories in the newspapers more and more frequently, because it's like the more we learn about the microbiome, the more we realize it impacts your health in so many different ways. At a basic level, it's like inside of your gut, there are all kinds of bacteria that live in there. So many different kinds of bacteria that it's like its own little biome. It's like its own little world of bacteria. And we're only just starting to learn about what lives in that world and how it works together, and how, if you have different bacteria and different levels of bacteria, how it affects your health in so many different ways. And so Dr. Sapaya was thinking, like, how does it affect vision? Maybe this affects vision in some way. And so he designed some really amazing experiments, which led him to a pretty strong conclusion that if you change your microbiome by eating a very, very high-fat diet with processed foods, like processed high fats, you change the microbiome in such a way that it actually causes increased inflammation. So that's a bad thing for all kinds of different diseases, including age-related macular degeneration, because inflammation and neovascularization, which is like when blood vessels form where they shouldn't form, these are things that you don't want happening if you want to keep your dry AMD dry. So he had this, quite convincing results that a high-fat diet, not good for the progression of AMD. And he's not able to join us today, but he sent me this publication, which is like hot off the press. And it's really cool because a research group has just published, they've built on his studies to look at the bacteria, the gut bacteria in people who have AMD, to see, it was amazing work with these animal models. Is it true in people too? And their results suggest that yes, that the gut microbiome does affect your vision, and it affects the development of blinding eye diseases. So one of the questions that came in was, what bacteria specifically? So I hesitate whether to answer that because I can't pronounce a lot of these bacteria. Should I give it a try? Okay. But so some of the bacteria that seem to be elevated in people that have age-related macular degeneration are Anerotruncus and Oscillobacter, as well as Ruminococcus torcus and Eubacterium ventriosum. So we can write those out in the comment section. But really, it's really cool to see when you have a beautifully designed study in the lab that it can really get further validation and move us towards new understandings of the disease when you see those findings start to work out in humans as well. So that's neat. And we had a question from Muriel, who in general just was hoping we could talk more about dry AMD. And we certainly will be talking more about dry AMD this year because it's one of those diseases that it's been very difficult to try and find like a magical pill to fix dry AMD. Right now people just prescribe these multivitamins, AREDS 2, and that seems to sort of keep it in check, stop the progression. But wouldn't it be wonderful if we had a treatment for dry AMD, since this is the form that affects so many people. And there are lots of people who are working on this, but it's been very difficult to figure out something that works because dry AMD, sort of like, going back to how I was talking about retinitis pigmentosa, that it's this umbrella disease that, the more we learn about it and the more we learn about the genetics behind it, the more we realize retinitis pigmentosa is many, many, many different kinds of rare diseases. The same kind of development is happening in dry AMD. So, we talk about dry age-related macular degeneration as this big umbrella term, and the more we learn about it, the more we realize that it's actually probably like many different kinds of dry AMD. And some of those kinds will progress into wet AMD and others won't, and others can be treated with this and not with that. But there is some really exciting stuff in the pipeline. We actually had Dr. Shelley Boyd give a talk at one of our education sessions last year, and she has a drug in the works that she really hopes is going to work, and we'll certainly keep you posted as more dry AMD developments happen throughout the year. So thank you for your questions. Now, I've been talking and I've made it through all three stories. I tried to answer many questions. Are there any more that have come in? Wonderful. Okay, if I missed you, you know what I did? I missed one question that I was doing some extra research on. So I want to answer that one just before I sign off. And this is a question from Sandra about the disease coloboma. So, and she wants to know if START therapy, going back to Dr. Gregory Evans' work, she wants to know if START therapy would work for coloboma. So, Sandra, I wanted to do my best to answer your question. And so, coloboma is quite a different disease than retinitis pigmentosa. So coloboma isn't one of those diseases that fits in that umbrella. It's a different disease. It is a genetic disease. It affects people at birth. And at birth, you're born with, if you have coloboma, you're born with various tissues of the eye that are missing. Really, it's that they didn't develop properly during embryonic development. And there are various things that doctors can do to try and fix coloboma. And right now, START therapy wouldn't be one of them, just because it's not one of these diseases that has the progressive degeneration of photoreceptor cells. It's a completely different thing that's going on. So in the comment section, I can share more about that disease. But it does show that it's not like START therapy will work for every single eye disease out there, but we are excited that and hopeful that it will work for more than just one disease. I see another comment about any other studies related to slow retinal degeneration. What vitamins are recommended when you have RP? So this is a good question, and something that this actual question came up during one of our education sessions last year. And the retinal chair of that session, Dr. Mike Dolan, I recall, had like a really nice answer that, for retinitis pigmentosa, doctors have been prescribing vitamin A, and there have been some studies that show vitamin A works, others show it doesn't necessarily work that well, and in the end, there's not really conclusive data that it works or that it doesn't work. So it's one of those things where it's up to you to bring this up with your medical doctor and talk about if vitamin A might be something that you would want to take. So he recommended, he's an ophthalmologist, and he said, often he will say if he's working with a patient who really wants to take it and it doesn't seem to be having any side effects, it's fine with him, but he doesn't like actively prescribe it either because it's, there's not great data to show that it works. But you also have to keep in mind that it's this big, retinitis pigmentosa. It's this big umbrella disease. It might work for some forms and not work for other forms. So I really encourage you, if you have like specific questions about your medical history and your medical condition, you absolutely should talk about those with your doctor. Now, I think that's a great place to wrap it up because we love talking research, and I could go on talking about research all day. And I do my best to try and talk about how the research that we're funding here at the Foundation Fighting Blindness and how research developments around the world, I want you to understand what they mean for you and how they impact the diseases that you are living with. But it's also really important that if you have really specific questions about your medical condition, you need to talk about those with your doctor. And that's always what we recommend. So with that, I think I'm ready to sign off. So I really want to thank all of you for tuning in. I really enjoy answering your questions, and I like getting to know you a little bit better. If you enjoyed this video, make sure that you like it and share it, because that's how we spread the word about the work that we're doing here, and it helps us to raise awareness about the importance of research for blinding eye diseases. I want to thank Dr. Cheryl Gregory Evans for joining us. It was great to have her online with us. And if you haven't already, please sign up for the FFB e-news. So I remind you to do that because these sessions that we have on Fridays are really designed to complement our monthly e-news. So our e-news goes out the first Tuesday of every month, and it's always full of exciting stuff, exciting research stories. And then the following Friday, we'll be having Facebook Live sessions where we get to talk in depth and answer your questions about the research, just like today. So if you're not signed up for e-news yet, you can do it right now. There's a link and description about how to do it in the video, above the video. It has been great talking research with all of you today. It's certainly been a fun way to end my Friday before I go out into a blizzard. Actually, the blizzard has stopped. That's good. I'm looking forward to seeing you all again soon. Thanks again for tuning in. Bye, everybody.